you're watching live or you're watching the recording, I just appreciate you watching. Thank you for joining me today. As we're getting started today, I wanted to have a look at CSV files really quickly. Well, maybe not so quickly. Let's see how long it takes us. Because I want to be able to, I want to make sure that everybody has the ability to be able to learn and understand how to work with your CSV files as you're approaching, trying to complete your labs today. So I want to make sure that they're able to do that first. So I want to do a bit of a programming example as we're getting started here today, just so we can ensure that we're able to do that. So let's switch over here and interrupt it. If I'm roboting, I would suggest refresh. If I'm roboting for you, I would suggest refreshing. I've got nothing on my end indicating that I am. I've got nothing on my end indicating that I'm losing anything. I don't know if this is a YouTube issue or what the deal is there. Give me just a second here. Better, worse? My nose shouldn't be clipping me that much, but I'll turn it off just to make sure it's not that. Is that it? Same. Okay. So it very well could be a YouTube issue here because it's not. My stream status is. I'm not dropping any frames. I have. Let's try to. Test, test, test. Test, test, test. All right, there we go. I think we've got it. Test, test, test. All right, there we go. I think we've got it. Test, test, test. All right, there we go. I think we've got it. All right, we'll just reboot my mixer there. When all else fails, reboot the mixer. All right, we'll just reboot my mixer. And let's turn my gate back on so you don't get all the room noise in there. Let me stop the local recording and restart it so I have a good version of that. It was good to hear what you all were hearing because it was not showing up as an issue on my end, so it must have just been my mixer throwing a little bit of a fit. All right, let's start over. So today, what I'd like to do first of all is I'd like to just kind of go through and examine working with CSV files. That's the first thing I want to do today is just make sure everybody understands how to work with CSV files so that we can all do well on our lab assignments today. And then we'll start talking about Module 10 and complexity and all that kind of stuff. Module 10 is primarily a theory module anyway, so we don't really have to spend a whole lot of time on module 10. So we will we'll start out by looking at some CSV files to get us started here. So I got a new replit here. I'd like to be able to work with a CSV file. And so what I'd like to be able to do here is to read and update a CSV file, and we'll also look at writing to this CSV file. The main thing that kind of trips everybody up every time is updating the CSV file. Right? It's all about updating the CSV file that's causing all of the issues. So I just want to make sure we're all able to do that. So let's start our program here. I've got a new replit here. I'm just going to add a file here. And we'll call this employees.csv. Right? And so I can make my CSV file directly here in Replit. I don't have to create it anywhere else. A CSV file is just a text file, as I believe one of the videos that I posted last week showed you all. CSV file is technically just a text file, just sometimes it opens in Microsoft Excel. So I want to make a few items here, right? I want to make a few rows here in our CSV file. So let's give everybody an employee ID number, a name, and an email address. Right? And so we'll just do a couple people here. Just so we can have some data here that we can work with, right? So I've got one record here for Dave, one record here for Anna. They are employees at my company. That we have an employee ID number here, which in this case it's just one, but it could be any multitude of numbers, right? Their first name and their email address, right? We can have as many fields here as we want in order for us to be able to, store this data persistently in our CSV file for our program, right? And the big trick to being able to update a file is it actually combines reading from and writing to a file into one action. Because essentially what we want to do is we want to read from a file. We want to store it into volatile memory in a data structure that we're used to working with. Then we can edit that data structure that's in our volatile memory. And then after we're done editing that data structure, we can write it back to the file. So let's start off by just making sure that we can read this file, right? Making sure that we understand that. So let's add our shebang here, hashbang /usr/bin/env python3. And we're going to be working with the CSV file here, so I'm going to import CSV. Right? Because that's kind of important if we're going to be working with CSV files. So what I want to be able to do is I want to be able to read a file. Typically what I will do is I'll have a function that I'll use for reading files. I will pass it the argument of the file name, whatever the name of my file is. And then we can open it, right? So we say C file equals open. File name being the file that we're opening. We're going to open it in read mode. And we're going to denote that new records are separated by our escape new line character. So a new line comes from escape new line. And then what we want to do is we want to take this. If we just tried to print this as it is, we see that what we end up with here, and I should call my function too, right? So if name is main,
read file, employees, and this should be in quotes, employees.csv. If we just try to print that out, we get a text wrapper. So we get an object in memory that we need to decode. And that's what the dictionary reader and the dictionary writer do, is they take things from, well, the dictionary reader in particular for this instance is it's going to take this text wrapper from our file and decode it into something that can be read. So we're still not dealing with anything in volatile memory yet. We're just taking sort of encoded, wrapped text, and when we read that, we're just sort of decoding it. So if we were to take this and say, oh, let's make a variable called reader, and let's say, oh, the CSV.dictionary dictionary reader function, we'll do that on cfile. And so now we've taken and we've decoded that object into basically another object, right? Like we've taken it and we've decoded it from a text wrapper into, if we print this now, if we print the results of reader, we see what we have is a dictionary reader object. So we've just decoded it from one type of object to another type of object, right? We've decoded it from a text wrapper object to a dictionary reader object. But if I iterate over this dictionary reader object and say something like for line in reader, the individual lines in the file are dictionaries, and so it will print them out as such. Now there is a bit of a problem with how we've done this so far, and we'll see what that is when I print line here and run. And so we see what's kind of happened here is that it's taken the two lines that we have in our CSV file and it's combined them into one dictionary, right? Because remember that when we're using a dictionary needs key value pairs. So it needs a relational key to be able to associate the values to. And so in absence of predefined fields, it tries to use the first line of the CSV file as the headers for that CSV file. Right, so I could go in here and I could type in some headers like ID, name, email. And if I went in there and I did that, then that's going to take that first line and use those values as the keys for those columns. Right, if we zoom in over here, for example, we see that now instead of trying to combine these all into one thing, it's using that first line as the keys and attaching them to the key value pairs of the dictionary. Right? Note that each line is its own dictionary, right? Because we can see that they are, in curly braces there. Each line is in its own set of curly braces. Now this is pretty good, right? Like this is something that I can deal with. But it gets a little tricky when you're reading to and writing from, or when you're writing to this dictionary, because of this particular line. If all you're going to do is append, pretty easy, right? You can append a row fairly easy here. Reading, as we see here, is pretty easy. Writing becomes a little bit difficult, where we're removing the entire contents of the file and replacing it completely. So what I like to do instead is I like to use fields, or what we call field names, rather. And so now we'll see that I removed that first line from here. So if I run this again, we'll see that it does that thing where it tries to use the first line as the keys. That's not what we want. So I'm going to create a variable in here called fields. And this is going to be a list or array variable. And I'm going to put those different field names into here. ID, name, and email. So now if I tell my dictionary reader object that the field names for this file are the ones that I have defined in fields, it will use those as the keys for the dictionaries instead of trying to use the first row in my CSV file. So if I run this now, we see that's what we get, right? ID1, name Dave, email dave@email.com. ID2, name Anna, email Anna@email.com, right? And if we go back, that row's not in our CSV file. It's only defined here in my Python in the fields property. And so with that, we're able to read from our file, and we're able to read from it relatively well, right? Like if I just wanted everybody's name, I could just access the different parts of this in the same way that we would access dictionaries. So I could access line, square braces, name, or line key name, and it would just give me everybody's name from the different dictionaries that are in our dictionary reader. Now the problem here is that our reader, even though we've decoded it and we're able to move over it, it's not a standard data structure that we work with. It's still a dictionary reader object. And as such, it's immutable. It's unchangeable. We can't directly change the things that are in our dictionary reader object. So if we want to make updates to a file, we need to treat it very similarly, but a little bit different, right? When we get to how we would update our file, basically, let's close this. All of these lines will be nearly the exact same, right? I just want to change what happens here in my for loop, and I want to add a little something to this. So I'm just going to take and I'm going to copy all of these lines of code that exist here in Reader. I'm going to create a update file function. File name, same sort of deal. And I'm just going to paste those lines in. Right? Because the first half of my update function is basically the same as reading. Right? We're still going to use these fields. We're still going to open our file in R mode. We're still going to use a dictionary reader. We're going to change what we do here. And we're going to add a data list, a data array. Right? So we're just going to add a little empty data list here. So what I want to do is I want to take each row out of my dictionary reader object, make sure it's well formatted as a dictionary, and then add that dictionary as an item to my array. So how would I do that? Well, I would do that by creating a temporary line. And so this temporary line is going to be a dictionary. And I'm going to use my same keys that I use, right? So ID is going to be the ID of the line. Line ID, comma, right? We're just building a temporary dictionary here so we can take it out of that dictionary writer object, put it into volatile memory, and then we'll store that into our data array data structure. Right, so we'll do the same with name, line, name, and we'll do the same with email, line, email. And then once we have that, we'll just take this temporary line and we will append that temporary line to our data array. So that'll be data dot append temp line. And we see that's all within this for loop for where we're iterating over our dictionary reader object here. Right? So we've taken this dictionary reader object, we've put all the data from that dictionary reader object into a data structure that we can manipulate that's in volatile memory. So we've basically just taken that file, we've opened it up, we've stripped all the data out of it, and we've put it into something that we can manipulate. Right? It's an array with dictionaries in it. We know how to work with all that. Right? So now all we have to do is we basically just have to work with this data field, right? We can forget about our file for a moment because all of our data is in this data field. And so let's say we take an input from the user and we take an ID for the user to update. And we can say, oh, well, enter ID to update. Right, so now I know that I'm going to have an ID number. ID number is going to be searchable. And so then I'm going to want to search my data volatile memory array of dictionaries to find a specific ID or to see if that specific ID is present. And so then we can just kind of start to do a similar process, right? So for item in data. So for each item in our data array, we're going to check to see if that item's ID value, we want to put an if statement here, if that item's ID value is the same as the ID that we want to update, then we can do some other stuff with it. Right, we can branch this out into all sorts of different conditionals here. We can do a ton of stuff with this, basically whatever we want to do. Right, like I could ask my user if they want to change the name or if they want to change the email address, and then change the email address or name after confirming it with the user. Right, and that's just adding more levels of conditions like we know how to do by now. But for our demonstration here, just to keep things brief, I'm just going to go ahead and change the name and change the email address for each user. So I'm just going to take that item, right? Because we're still in this one item here. So when we found an ID that's the same as the ID we want to update, we're stuck in that one dictionary that we're currently in as we're iterating over our data array of dictionaries. And we can say, okay, item name, so the name value for this item, we're going to set it equal to input enter new name. And the item email value is going to be set to input enter new email. And so in that, we know that when we take the key and assign it a new value, then we're going to update that value. And we're doing it all in temporary memory. Right? So at this point, we've changed the data that's in our data array that is in our volatile memory. So now all we really have to do is take that file from volatile, or take that data from the volatile memory and write it to our non-volatile CSV file. And so all I'm going to do here is I'm going to open that file back up, right? So we're going to take C file. We're going to open it back up. So we're going to open it, file name. This time we're going to open it in write mode. New line is still going to be our escape new line character. And instead of a reader object, we need a writer object this time. So we'll create a variable called writer. We'll set it equal to csv.dictionary_writer, DICT writer. We're writing to the C file. We're still using the same field names. So field names equal fields. And then we can just iterate over our data array here. So for line in data, we are going to writer.write row line. And then we can close the file. C file dot close. So again, what we've done here, right? We've taken what we had in non-volatile memory. We've opened it up. We iterated over it and took all the data out of it and put it into a data structure in volatile memory, which is our data array here. Then we can manipulate that data structure that we have in volatile memory, just like we were doing over the last couple of modules, right? Just as we were working with lists, as we were working with dictionaries, we manipulate this item now in the exact same way. And then when we're done manipulating that item in volatile memory, to the extent that we want to manipulate it, we can do whatever we want with it while it's still in volatile memory. We say, okay, now we're going to transfer you back from volatile memory to non-volatile memory and go through all of this. And if you wanted to, you could do this in different functions, right? Like I could put the read in its own function and just return the value of the dictionary reader object. And I could have another function that takes the dictionary reader object and puts it into volatile memory and return that list, return that array. And I can have another function that writes that back. And that would actually probably be the smarter way to do that. Because we'd have even more modular code here. So we'd have even smarter code that we could work with. But, you know, for the time being and for where we're at and the scope of this course, this is perfect. This is fine. Right, so let's say our friend Dave here. And we'll change this function call here to update file instead of read file. So let's say our friend Dave here doesn't like to be called Dave. He would prefer to be called David. Right, and so we'll change his name in the system to David. And we will change his email to david@email.com. Right, so let's run our program here. The ID to update, we know David is ID 1. His new name is going to be David. And his new email is going to be david@email.com. And it's done, right? We didn't print anything out of our update file function here. We just pushed it all into the CSV file. So we'll know if it worked if we open the CSV file, and Dave is now called David, which we see is the case here. And maybe similarly, right, maybe Anna doesn't want to go by Anna. Maybe Anna goes by Anne. So let's update her information. Let's say, oh, 2. Well, Anna is now Anne, and she's going to be Anne@email.com. And if we flip back over to our employees.csv, we see it's updated perfectly here, right? Exactly what we want. Now, what if I told you that we could also write to this file directly from here, write a new record to this file without doing much else? Right? So we can create new users from this place as well. So one of the interesting things, and we mentioned it while we were going through loops, is that in Python, loops can have else statements. So a for loop can have an else statement. So my for loop here on line 32, that's looking for the item in my data array data structure. Well, what happens if it doesn't find it? Well, if it doesn't find it, we can use an else file, an else statement. So what we would want to do here is we would want to put a break here as a part of this if statement. And we'd really want to do that anyway, because once we find the user, it's okay if we stop iterating over our file, right? We'd want to put a break here anyway. Because, you know, with our example here where we only have 2 records, it's going to go through them all really, really quickly. But if we were to go through a whole big file of records in a flat file like this to kind of parse through them, and say we had file 50 in a 1,000 record database, then you'd be parsing 950 extra items that you wouldn't need to parse if you included the break statement here. Because the break statement is going to stop the loop once it hits that break statement after it executes this condition. Right, so now we're going to pair our else statement here with our for loop instead of our if statement. And so what we're essentially saying here is for item in data, well, if it's not found in data, then we can do something else with it. And basically what we would do with it is this. Again, right? We just put new values in with these keys. Right, so I'm going to copy that. I'm going to copy this temp line equals dictionary down through data.append. I'm going to copy that. I'm going to paste it behind this else statement. So I'm going to create a new temporary line. In this case, the ID is going to be ID update. The name is going to be input enter new user name. The email is going to be input enter new user email. And I might want to start off this else statement with a statement like print user not found adding new user. Right? Or you could also say something like, you know, you could put this behind a condition. and say, would you like to add a new user? Yes or no? And if it's yes, then we do this. And if it's no, then we just kind of ignore this. And maybe we flip it around and recurse the function and jump back up to the top or something like that, right? So now with this, we have the ability to add a line. Since we're adding it to that volatile memory list, this part here writes everything from the volatile memory list to the file. So we can add a new user from the file here fairly easily. So let's run this. Enter ID to update. Well, this time we're going to enter ID 3. We get that the user's not found. We're adding a new user. Well, let's add Sarah. And Sarah will be sarah@email.com. And in our CSV file here now, we have Sarah's line. And now, since that's loaded in the file, it's always going to be in that file. So if I find out, oh, Sarah isn't Sarah with an H, Sarah is Sarah with no H, I can enter it to update Sarah with no H, sarah@email.com. And if we look at our file now, it is Sarah with no H. And so that's updating a CSV in a nutshell here. So in this instance, we have read, we've written, we've updated to a CSV. So before we continue on, and I will give you all this file with the recording today. What are your questions? It's not as difficult as it looks, right? Like it is relative. Like when we break it down, it's basically just a bunch of stuff that we know that we're just doing in a particular order, right? So, it's just that understanding of, okay, well, when do we do the things that we know? We'll hold just 1 or 2 more minutes here for questions before we continue on to our information on complexity and algorithm. A brief run through of each function to just tell what the function does. Sure. So we can go line by line here, right? So if we look at our read file function here, our fields line here, line 5, what that does is that creates a list variable that has what I want to be the keys for my dictionary when I put it into my dictionary reader. Right? So this is where I'm defining the keys for my columns in my CSV file here. Right? So if I look at my CSV file, I see that I have 3 items separated by commas. So the first item in my fields list here goes with column 1, second with column 2, third with column 3, so on and so forth. Right? So if we wanted to add more, we could. Then in line 6 here, I am opening the file. So this takes the file, it creates a text wrapper object where it is taking the file, and I have like an encrypted file that is available in my program for me to do things with. So I'm opening a particular file name, right? We're passing that in as a parameter. In this case, I'm opening it in R mode or read mode. And I'm denoting that every new record or new line is created with an escape new line character, which is my line break. Right? So when I'm going through this and you get to a line break, it's telling it that it is a new line and a new record. Now my text wrapper object is encrypted, right? It's a special type of file, so you can't read it on its own. So I have to decrypt it with this dictionary reader so I can have something that we can read. So it basically just takes that encrypted file and converts it to a dictionary. And so the keys are the keys that we defined here in line 5. So that's what we have here with these field names equals fields. The field names are just that's the keyword here for the keys for each dictionary. And then in this instance here, what we're doing, we're just going through that reader item there, which is my dictionary reader object, printing out the name value from each line. Now the problem with that, right, is that a dictionary reader object is immutable, right? So we can't change items in place inside of a dictionary reader object. So we need to be able to move the data from our dictionary reader object into something that is mutable if we want to change it. And so we know that dictionaries themselves are mutable, and we know that lists/arrays are mutable. So when we get into our update file here, we're bringing in a file name as a parameter. Most of these lines here are exactly the same as we saw them in the read file function here. With the exception of, we have an empty array that we've given the name of data. And that's going to be our mutable data structure that we can take each dictionary out of our immutable dictionary reader object and put it into, so that we can then iterate through all of the dictionaries in this array and make changes to them. Right? So line 16 here, that's the same as line 5 here. Line 17 here is the same as line 6. Line 18 is the same as line 7. Right, we're doing the exact same things in both of those. Or in all three of those, I should say. And so with that, right, I'm going to iterate over that dictionary reader object the same way we would do here to just get it to print things out. But instead of printing it out, I'm going to create a temporary dictionary in volatile memory that I can then push to this data list, right? So that's what I'm doing here, is for each dictionary in my dictionary reader object, I'm creating a temporary dictionary with the key and the value for each item in there. And I am pushing it. I'm using this data.append, this .append function, to append that line, that dictionary line, to data. And that's just adding a data or a dictionary, that dictionary item to that data array. And so it's going to add a new dictionary from my dictionary reader object for every single dictionary that's in the dictionary reader object into my data array. So now I have something that's mutable. I have something that I can work with, and that's that data array. Right? So I don't have to worry about that file anymore for a little bit. Right? I can close the file, and I can just start to manipulate that data array. And so I have a list of dictionaries in my data array now. And so what I want to do is I want to say, well, which record do I want to update? Which record do I want to change? I have to have a point of reference so that when I'm looking through this array of dictionaries, I know which one I want to use. And so that's what we're doing here with this input. And so here with this for loop, we're saying, okay, well, look through this dictionary, look through this list at every dictionary, right? For every dictionary that's in my data list of dictionary. If the dictionary key ID in that particular dictionary is the same as, if the value for the dictionary key ID in that particular dictionary is the same as the ID that was entered here that I want to change, then it's going to know, okay, I found the right dictionary. I found the dictionary that this person wants to change. And so now I can make changes to that dictionary in the volatile memory. Right? I can take item name here, which is the key for the name property in this particular dictionary, and set it equal to the user's value that they input at input enter new name. Do the same thing with email. Right? Find that email key, change the data that's in that email key to be whatever I want the new email to be. And then once I've found that right dictionary, I want to stop my loop. So I'm going to break there. And break's going to break me out of this for loop. Because like we said, right, like if I have a 500 record array, 500 record list, and I need to work with record 14, right? I don't want to go through the rest of the records when I don't have to, right? That's inefficient. Now we can use an else statement with a loop in Python. So we can say, well, for item in data. And then this will run if the item is found. But if the item is not found, if we go through the entire data array and we get through it and we've not triggered this break clause, then we know, okay, well, that ID isn't in our flat file here. It's not in our CSV file. So we can add a user, and we basically add a user the same way that we were adding it here. We just do it a little bit differently, right? We create a temporary dictionary that has all the right keys for the values, right? The value for the ID key in this case is going to be the value that we entered for ID update here. And then we'll get a new value for the name key, a new value for the email key, and we'll take that dictionary and we will add it, we'll tack it on to the end of our data array. And so with that, once I'm happy and I've made the changes that I need to make or made the addition that I need to make, then I can open my file back up. Right, so that's what we're doing here. We're opening our file back up. This time we're not opening it in read mode, we're opening it in write mode. And remember that when we open a file in write mode in Python, it immediately deletes everything out of the file. Right, so everything gets deleted out of the file and we're writing to a fresh file basically. But since we have all the data that we need to use stored in a data structure in volatile memory, we can just take all of that and just write it all back in there. So we create a dictionary writer object here that looks similar to that dictionary reader object, but it's not for reading It's not for converting our file into a dictionary. It's for converting a dictionary into something that works with our CSV file. And so for each line in our data array of dictionaries, we want to use our writer variable, which is this csv.dictionaryWriter, to write a row of that particular dictionary that's a part of that data array to my file. And it's going to do that for every single dictionary that's in that data array, whether it was updated or not. Right? Because remember, here at this point, everything was deleted. So it was all deleted back out, but it's cool because we have it saved in volatile memory, so we can just put it all right back. And that gets us everything back. And so then we can just close our file, and we're done. Right? We're good to go. And if we wanted to, right, we could even just kind of tack on read file file name here at the end. So we could even just print the names that are now in the file, because I think that's what we ended up with here. We were only printing, the values that go along with the name key for each dictionary item. So we can at least get the names that are in the file there. So if we wanted to run this again now with update file here, which is behind our main gate, let's say we want to add a new employee, employee 4, user not found, adding new user. The new user name will be, let's say Carl. New user email is going to be carl@email.com. And now we can see Carl's been added to our output list here. We have David and Sarah and Carl. And if we look in our CSV file here, flip that over, Carl's information is there as well. What if he was Carl with a K? Well, we can update record 4. Carl is Carl with a K. And it's Carl with a K @email.com. And we can see that he's now Carl with a K. And so that's basically everything there, line by line, just sort of given back to you. So with that now, what are your questions? I want to make sure everybody understands reading from, writing to, updating CSV files. These come in handy. These come in handy when you're writing programs. Because I mean they're essentially a database. Right? If you can remember back to when you took the CTI 110 class, we mentioned databases, and one of the types of databases that we mentioned was a flat file database. And for all intents and purposes, that's the role that our CSV file here is serving. Our CSV file here is serving the role of a flat file database. So for all intents and purposes, we have a table here that we can update, that we can read from, that we can write to, that, we could query for all intents and purposes if we were of the mind to. But it's not a complicated, like, MySQL database or something like that. It's just a simple, flat file CSV document that we can work with. And if you need an extra day or two to complete this lab assignment, it is probably one of the tougher ones. Feel free to take it. right? Module 10, and it looks like we won't have much time for Module 10 here because I do have another live stream scheduled for 4, so we'll have to be departing. I'll post a pre-record for Module 10. Module 10 is basically Module 10 is a theory module anyway, right? When we're talking about algorithms, because the whole idea when we get to this point is that basically, we've looked at how to write things. When we are at this point where we are just getting started, right? We're not as concerned with writing things in the most efficient manner possible, right? Like writing software for efficiency when you're first learning how to code is not something that you particularly worry about, right? Like it takes some people until they are, several years into a career before they start worrying about writing code for efficiency. And so when we're examining algorithms in that sort of way, one of the big things that we're talking about there is the idea of big O notation, complexity. Right? And there are different types of complexity. There's time complexity. There's space complexity. With the whole big deal being basically what you do with your program, how you write your code, and all of the different actions that your code takes, all your different loops, all your different conditionals, all your different assignments. Every line of code that you write contributes to complexity. And one of the things that we discuss in this module is this idea of the separation of performance and complexity. Right? Because performance is going to be based on a specific item. Right? Like your computer, for example. If you have a brand new i9, 64 gigabytes of RAM, big hard drive, big graphics card, your computer is going to have a higher level of performance than, a computer made 20 years ago. Right? So a program will run faster in general on a fancy high-end computer than it would on an older computer. But that's performance, right? Because it's dependent on the machine. Complexity, when we're thinking about complexity is relative. So a more complex program is going to relatively take longer on a machine than a less complex program, regardless of the type of hardware or whatever you're running. Right? And when we get at scale, it might be nanoseconds. But it is something that happens. And so I will save this I'll save this for a pre-record, but I will show you all sort of a demonstration that I've done previously for this. So let me just find that and so that I can show it to you. If I can find it. Let's see here. Let's find it from around this time last year. Here we go. Normally, to help explain this, and you all will see this in the pre-recorded video where I write this code, I show you all the difference between, I explain complexity in relation to bubble and merge sorts. So this will mean more to you as you watch the pre-recorded video. When you get to that point, but a merge sort is more efficient than a bubble sort. A merge sort is O of n times log n in time complexity, which, doesn't mean a whole lot to you at this point, but once you get the pre-recorded video behind you, it'll mean a little bit more. And the bubble sort is O of n squared. So the logarithmic factor of n is lower than n, right? So n times the logarithmic factor of n is a lower value than n squared. So the merge sort is more efficient. And so we can see this in this demonstration that I have here. Right? I have two files here, or two functions here, that I comment and uncomment out. And they're sorting the values that are in this set.py file here. And so if I look in this set.py file here, I have lots of files, or lots of numbers in here, lots of big numbers to sort. I believe this is 1,000 values. It might even be more than that. I don't quite remember. It might be 5,000 values. Let's see what happens if I try to run the bubble sort, which is the less efficient. They both do the same thing, mind you, right? They both are going to put all of these numbers in numerical order. But the bubble sort is less efficient than a merge sort. So let's see what happens when I run the bubble sort. So note that our file is running. The button up there still says stop. It still says stop. It's going to say stop for a while. This is running. This is working in the background. If you look in the lower left-hand corner, you can see my CPU working. And there we go. Right, and it took all those numbers and it sorted them out. It took a long time to do that, right? Like, we're not used to our program, with the programs that we've been running in this course, we're not used to a program taking that long to run. But due to the complexity O of n squared of the bubble sort, it takes a while to run. Now let's clear out my console. Let's comment out the bubble sort, and let's uncomment the merge sort. So again, remember, these two things are doing the exact same thing. They're putting all the values in that set.py in numerical order. And so if I run this now, it's already done. Click the button. Done. Right? So we saw, like, we had to sit and wait on the bubble sort to execute whereas our merge sort was almost done instantaneously, and there are even faster sorts available, and there are even slower sorts available. That's one of the questions that you have to answer for one of your Module 10 labs, is the slowest sort. And the slowest sort is kind of a meme sort, which it is kind of funny. So we'll let you all discover that one. So with that being said, I will go ahead and start to wrap things up here. I will put out a pre-recording for complexity for Module 10. Are there any questions still about any of the CSV material that we were looking at, or just kind of what we've introduced here for complexity? I should probably change the title of this stream based on how little we actually talked about complexity. The recording that'll get posted has all the audio issues from the first part trimmed out. So when I go back and post the recording of what we've done here, it will have that first part trimmed out. I restarted the local recording after all that. So I think we'll be good there. Seeing no questions, we'll go ahead and wrap it up. Thank you all for watching. If you have any questions, or you come up with any questions later on, or if you're watching the recording and you have any questions, please let me know. We'll see ya next time. We will have one. We'll have a live stream next week, and it'll probably be our last one. Because, that'll basically be it. So, thanks, and we'll see you next time.